In this video we're going to look at 4 examples which puts everything that we've learnt so far together. The most important thing about working with straight lines is being able to express the equation in the form y equals mx plus b, so that we know information about the slope and we know information about the y-intercept, or indeed y minus y1 equals mx minus x1, where we know information about the slope and a particular point the line passes through. These are the most useful forms of the line, but unfortunately they're not the only forms of the line. And the third type is called the general equation of the line, which is what we have in this example here. The general equation of the line is generally not the most useful, apart from with intercepts, which we saw in the last video. So it's often necessary to rewrite this in a more recognizable form. You will notice that y equals mx plus b has y by itself and y is positive. So in our example, 4x minus 5y minus 30 equals 0, we really need to get y by itself and indeed the y positive. So let's move the minus 5y onto the right hand side. So this gives us 4x minus 30 is equal to plus 5y, and then we don't want 5y, we want y, so let's divide everything by 5, so we'll end up with 1/5 of 4x minus 30 is equal to y, or in other words y is equal to 4/5 x, and then 1/5 of 30 is 6, so 4/5 x minus 6. This is the slope-intercept form, and we can see straight away that the slope is 4/5 and the y-intercept is minus 6. Now, going back to the previous video, 4x minus 5y minus 30 equals 0 is actually a really good method to find the intercepts quickly. If we ignore the x, if we let x equals 0, then we're left with minus 5y minus 30 equals 0, or in other words 5y equals minus 30, so y equals minus 6. In other words, 0 minus 6 lies on this line, which is of course a y-intercept of minus 6. Instead, if we let the y term equal 0, then the y term disappears and we're left with 4x minus 30 equals 0, so 4x equals 30, so x equals 30 divided by 4, which is 7.5. So we have a y-intercept of minus 6 and an x-intercept of 7.5, and again this corroborates what we had from the slope-intercept form, a y-intercept of minus 6, which we have, and a slope which is definitely positive but less than 1. So we've definitely got this one right. In this second example, we're asked to find the general equation of a line passing through 2 points. Well, remember, this is the only information we need really, because from these 2 points we can get the slope, and we can also generate y minus y1 equals m x minus x1. So firstly, let's figure out where these points are. Minus 2, 7 is somewhere up here, and 10 minus 9 is somewhere way down here. So the line we want is something like this. So in order to work out the equation of the line, we're going to need y minus the y coordinate equals m x minus the x coordinate. Well, we have 2 coordinates, so we're good there, but we do need to find the slope. So m, which is the slope, is best achieved by looking at the difference in the y coordinates divided by the difference in the x coordinates. So we have y coordinates of minus 9 and 7, minus 9 subtract 7, and x coordinates of 10 and negative 2, 10 subtract negative 2. This gives us minus 16 over 12, which is minus 4/3. Now we know the slope, we can substitute one of the coordinates into the formula. Let's use 10 minus 9. Y minus the y coordinate is equal to the slope minus 4/3 x minus the x coordinates. y minus negative 9 is the same as y plus 9. Now, the point of the general equation is that the coefficients of ax plus by plus c are all integer. In other words, it serves to get rid of any fractions. So we have division by 3 here, so let's multiply throughout by 3 and that will get rid of it. The left hand side becomes 3y plus 27. The right hand side, which is currently minus 4 divided by 3 times by x minus 10, when we multiply it by 3 we'll be left with minus 4 times x minus 10, which simplifies and expands to minus 4x plus 40. Now, the general convention is that we start with positive x, and we have minus 4x right now, but if we moved it on to the other side it would become positive, and so we'd have 4x plus 3y plus 27 equals 40, and then moving the 40 over we finally end up with 4x plus 3y plus 27 minus 40 equals 0, or in other words 4x plus 3y minus 13 equals 0, which is the general equation of the line. In this third equation, this is similar to the ones we did on perpendicular and parallel lines. We have a point that the line must pass through, and we know information about the slope of that line. It needs to be parallel to the line passing through these 2 points. So let's figure this out. Minus 9, 8 is somewhere over here. We have a point over here, and the line needs to pass through there, but it needs to be parallel to the line passing through 2, 3 and 8, negative 12. So here's the line that it needs to be parallel to, so it's going to be something like this. First off, we need to find the slope of this line. So the slope is the difference in the y coordinates over the difference in the x coordinates. Minus 12 subtract 3 divided by 8 subtract 2, or in other words minus 15 over 6, which is minus 5 over 2. So the slope of the line we want is the same. 2 lines are parallel, they have the same slope, and it needs to pass through minus 9, 8. So y minus the y coordinate is equal to the slope x minus the x coordinates. First things first, let's simplify the bracket. X minus negative 9 is the same as x plus 9. Now, the general equation of a line serves to get rid of any problems with fractions and have integer coefficients. So here we have division by 2, so let's multiply throughout by 2. The left hand side becomes 2y minus 16. The right hand side gets rid of that division by 2, so we're just left with minus 5 times by x plus 9. So 2y minus 16 is equal to minus 5x minus 45. We wanted all the coefficients on one side equal to 0, and we needed to start off with positive x. So let's move the x over. So we're left with 5x plus 2y minus 16 equals minus 45. And then we want everything set to 0, so move the minus 45 over, and we're left finally with 5x plus 2y minus 16 plus 45, or in other words 5x plus 2y plus 29 is equal to 0. And this final example is perhaps the most comprehensive of all. Find the general form of the equation of a line passing through a known point which is perpendicular to the line whose general equation is something else. So the known point is minus 4, 7. Okay, we know the point. If we knew the slope, we could go further, but we don't know the slope. However, we do know that it needs to be perpendicular to this equation. Okay, well that's a start. So 8x minus 3y plus 16 equals 0. This doesn't really tell me anything. I need it to be in the form y equals something x plus something. So I need to convert this to something more recognizable. So let's move the minus 3y over to make it positive. So 8x plus 16 is equal to 3y. And now divide by 3, so y equals 8/3 x plus 16/3. Oh, this gives me lots of information now. So the y-intercept is 5 and a bit, 16/3, and the slope is quite steep. So the line I actually want is perpendicular to it, and it goes something like that. Okay, so the slope of the line we've just worked out is 8/3. So the perpendicular slope is the negative reciprocal. Tip it upside down and change the sign. Instead of being 8/3, its slope will be minus 3/8. Okay, minus 3/8, and it needs to pass through the point minus 4, 7. So y minus the y coordinate is equal to the slope x minus the x coordinate. Let's simplify the right hand side a little bit. Y minus 7 equals minus 3/8 x plus 4. And again, now the whole purpose of the general equation is to get rid of any fractions. We have division by 8 here, so let's multiply the whole expression by 8, and that will get rid of that fraction. So we will have 8y minus 56 is negative 3 times by x plus 4. 8y minus 56 is negative 3x minus 12. But again, we want the coefficient of x to be positive, so let's move it over to the left hand side. So 3x plus 8y minus 56 is equal to negative 12, and then bring that one over 2 to make it into 0, and we'll have 3x plus 8y minus 44 equals 0. We can use the general form to double check by considering the intercepts, which we talked about last video. The y-intercept is when x equals 0, and if x equals 0, we're left with 8y minus 44 is 0, so 8y equals 44, so y is 5.5. And if y equals 0, we're left with 3x minus 44 equals 0, so 3x equals 44, so x equals nearly 15, 14 and 2/3, which is absolutely consistent with our diagram. This is correct. So please revisit these videos, go through them carefully and slowly, take your time with each one, understand the process, and then practice, and hopefully this all makes sense.